Welcome and thank you for joining us as we peer into the future of rooftop units and air handling units. We want to talk a little bit about how the changing regulations in Europe in particular will affect these applications and some of the solutions that Danfoss has that can help you address those as they come into play. We are welcoming experts from really all over the world today. We have people from all over Europe and America as well. I'll introduce these guys as we go, but we have experts in lots of specific areas to give us their views. But before we start, I'd quite like to start with a broad issue, because I'm aware that some people in the audience will be, depending on where they are in the world, might be much more familiar with either air handling units or rooftops, but perhaps not both. So, Philippe, could I start by asking you to give us a brief introduction to the two?
Yes, for sure, David. Rooftop units are generally mounted on the roof of building to ensure their thermal comfort. Air handling units are installed inside or outside the building, while a rooftop unit and air handling unit can sometimes be very similar. Air handling unit can provide generally more sophisticated air handling functions than what is available on rooftop units. This makes them more suitable for use in a specific process application and not only on comfort air treatment. The air handling units are configurable at will according to the need of the customers and generally use centralized energy production, while the rooftop unit embed most often cooling and heating production.
Thank you. That really clarifies things. Can I just ask, looking to the future, what you think are the main factors that are going to influence the design of these units?
Yeah, directives and legislation related to direct and indirect CO2 emissions are the main current factor influencing their design. So we have already some energy standards and directives applicable in Europe, such as eco-design for rooftop, chillers, but also condensing unit, air handling unit, and so and so. And these energy standards focus on the system efficiency over the full year and not only on full load, but also on part load. They are defining a minimum requirement. These eco-design requirements in Europe have already been in place since 2018, and a new step is coming soon in January 2021. And this eco-design is part of the European Green Deal.
And I think that's a new thing, isn't it? Because I mean, we talk about eco-design quite a lot, refrigerant change, all of these other regulatory changes that are going on. But there are new things happening with this European Green Deal, I think. Eric, could you tell us a bit more about that?
Yeah, the European Green Deal is proposed in 2019, and it's an ambitious political project that combines environmental protection and economical growth into one strategy. The target or the objective is to have by 2050 the first carbon neutral continent in the world. And from the ongoing European COVID recovery discussions, it's already clear that this Green Deal is going to be a major driver in the process and the rules for giving the subsidies to the economy.
So it sounds like that COVID is really changing the picture there, but you mentioned carbon neutrality. What kind of things can we do to address that in Europe?
One way to come to this carbon neutrality is looking to the usage of energy. And within the Green Deal, 2 out of the 5 main initiatives will as such impact the usage of air handling units and rooftops, namely the renovation wave, what will impact the energy performance of the buildings, and the strategy for energy system integration. What will be related to the usage of heat pumps or the reusage of waste heat coming from other parts of the buildings.
I see. So you've got these big market-wide changes, and they're going to make a significant impact on overall system design. Thinking about the selection of components, though, as well, yes, but could you give us a perspective from Danfoss Drives? What's up on your side? What's new?
Sure, David. Well, in Danfoss Drives, we are truly focused on developing innovative solutions for air handling units and rooftop units. So in order to facilitate the monitoring of filter conditions and airflow control in air handling units and rooftop units, we developed the pressure transmitter PTU 025. It is indeed a very innovative solution. It's meant to fulfill the latest Eco-Design Directive ERP in order to reduce energy consumption in air handling units. It has intelligent filter monitoring and airflow control based on 4 built-in pressure sensors. Integrated, as you see here, at the bottom of the variable speed drive, VLT HVAC drive, FC102. It's easy to install, and it presents data on the LCP and in the connected building management system. So adding the PTU 025 on air handling units and rooftop units significantly reduces complexity and cost by making expensive differential pressure gauges and flow meters redundant.
So that sounds like that could have a big benefit there. Thank you. It sounds promising. Anything else that you can share about on the filter management side for air handling units?
Actually, majority of filters in air handling units and rooftop units are either replaced too late, causing severe energy losses due to the fans operating against clogged filters, or they are replaced too early in scheduled maintenance, meaning that the filter lifetime potential is not utilized. In addition, poorly maintained filters significantly increase the risk of airborne infections and jeopardize the indoor air quality, which is, of course, very critical under the current conditions. In addition to a safe and healthy indoor air quality, significant savings will be obtained in the operation. Ensuring a timely filter replacement in a mid-size air handling unit, as you see here in the slide, at recommended pressure loss over the filter of 210 Pascal instead of too late when the pressure loss over the filter reaches 420 Pascal, typically brings savings on the energy bill of up to 2,000 euro. That's per year. So we talk about serious savings here, David.
Yeah, sounds like it. Thank you, Jesper. I think the building users in particular are going to really like that one. Stanley, I'm keen to talk about the hydronic side of the installation. What's new there?
Yeah, David, thanks. Yeah, for sure. Danfoss also offers some new solutions this year for the hydronic side of air handling units and rooftops. And what we're always looking at, solving actual challenges that are in the market. So where we're going right now is, we have a lot of challenges when it comes to, commissioning and on-site work that actually requires physical presence at the site, and then there's also a lot of issues with controlling the temperatures and the humidity, and also transparency actually in the system. So where is energy going? What is the actual status of the system, and what's the wear and tear on the components is also usually not there. So what we have now is we're going with actually really data-driven solutions, and our ABQM with Novacon IoT actuator can now basically move a lot of additional data to the system, and that means you can do basically all the commissioning from the system, so from behind the computer. Then we have also the perfect control because it's pressure independent, so we always have the right temperature and the right flows. And because we have so much more data, we now have a very precise insight in the system. So we know exactly where the energy flows are going. So if there's any waste there, for example, or there's something wrong, you can immediately step in and correct it. And there's also the wear and tear on the components, as well as the actual status of the system that you can now monitor quite closely. So your maintenance, instead of being reactive, can now be predictive.
Oh wow! So that sounds like there's a lot of benefits there. Thank you very much. Moving back to the cooling circuit, I mean, obviously, refrigerant change is an issue that we can't ignore. Eric, have you got any view there on how you see the future?
Yeah, if we look January 2021 and onwards, we might see more and more refrigerant changes, and these will impact the energy performance both on cooling and heating side of the air handling and rooftop units. But the refrigerant future as such is not really clear at this moment, in particular for systems with direct expansion. The reason is that all these changes of new refrigerants towards low GWP or low global warming potential refrigerants, they still involve at this moment flammable refrigerants, even if it's only light flammable. And there's quite some unwillingness of people to use it, or sometimes there's restrictions due to the city or the regional government. But the moment that there's more acceptance of these new refrigerants, we have the products ready to have compressors alternative to 410A proposed to the customers. And then we are talking refrigerants like R32, 454B, 452B, viable options and already today available.
So there's a lot going on there. So how does that affect product development on the compressor side?
Well, on the compressor side, looking to the fact that air handling units have more and more cooling circuit integrated, they have also more and more reversible cooling systems integrated to take care of the heating by means of a heat pump. When the air handling unit is making use of heat recovery, then the exhaust air is used to maximize the energy efficiency of the system. And a side benefit is that at that moment, the evaporating temperature of the compressors used in the heat pumps is increased, what's again in the benefit of the system. Besides, when it comes to rooftop units, we see more and more that big compressors get replaced by multiple smaller compressors in tandem. And then in particular, making use of our DSH with intermediate discharge valve. And this is in fact a very simple, economical solution that can be used as a drop-in for existing tandem design. In case we are talking about R32, for that we have also a dedicated compressors with intermediate discharge valve. And then we are talking about the DSF.
So it sounds like there's quite a lot of importance there with the drives with these units as well. Variable speed scrolls seem to be particularly important for RTUs and AHUs as well. Why do you think that is?
If we look to air handling units, the use of the variable speed compressors is quite commonly already used. In particular, when it comes to the heat pump part, and there we are, for example, using our VZH up to the VZH 88 in air handling units. If we look to rooftop units, these need to comply with both heating and cooling requirements from the eco design. And that makes that likely the usage of variable speed will quickly increase from 2021 onwards. In particular, if we are talking about rooftop units 20 to 80 kilowatt. sometimes people say, hey, drive is expensive, but in fact, if you look to the total applied cost of putting a tandem together, also doing the control, then a drive solution is not that more expensive, if more expensive. So it's interesting to look at the usage of variable speed from the total applied cost perspective. Certainly for installations up to 150 kilowatt, it's very economical.
That's good to know. Thank you. And it's, I mean, obviously the compressor is ultimately really important in the cooling circuit, but there are plenty of other opportunities with other components too. Vic, I was wondering if I could bring you in here to talk about some of the broader range, maybe sensors, heat exchangers, or expansion devices.
Yep, absolutely. Thanks, David. Yeah, for sure, when you're designing your rooftop unit, you start with the compressor. That's going to get you the capacity you need. But very quickly, you need to select your heat exchangers to get a good heat balance, and then your expansion valves and all the other components in the system. Now, fortunately, Danfoss offers all of these components, so we can readily help you select all the components needed for that rooftop selection. And when working with Danfoss, if you look, we have some technologies that work much better together. So, for example, Eric has already mentioned our DSH scroll compressors with intermediate discharge valves. Those compressors, if you're going to apply them in a system, will give you probably a 5 to 6% efficiency increase, which is a very good increase, right, for a simple change like that. Danfoss has also developed an interlaced microchannel coil, which can be used both as a condenser and an evaporator. And when applied in a rooftop system, you can expect to get about a 4 to 5% efficiency increase in the system. Again, a very nice increase. However, when you take both of these technologies, put them together, right, that's where you really see the benefit, and you can get about a 12 to 13% system efficiency increase by using them together. So here, by using all the Danfoss components, you really get a 1 + 1 = 3 kind of benefit.
Yeah, wow, that's definitely worth having. And you're being kind of modest there, I think, because the interlaced microchannel heat exchanger, that's the one that won the Innovation Award at AHR recently, right? Anyway, I know that you also wanted to say something about liquid injections. Could you tell us about that?
Sure, and yeah, thanks for the shout out on the interlaced. Absolutely, we won the Innovation Award at ASHRAE, which now seems so long ago for many of us. But yeah, for sure, to get your compressor and your heat exchangers working right, you need to make sure you've got good control of the refrigerant as it's flowing through the system, and that, of course, is done with an expansion valve. Danfoss offers many options for you here, and if you're running with a variable speed or variable capacity system, then an electric expansion valve or EXV is going to be the best way to go. And Danfoss has our ETSC Colibri valve. It's good from about 40 to 500 kilowatts or 12 through 140 tons. And it's designed for use with these high-density R410A-like refrigerants. And it's also qualified with the A2Ls that Eric mentioned, R32 and its derivatives, R454B and R452B. To control the valve, we have EKE Superheat Controller. It's got algorithms built in to ensure you're running at what we call the minimum stable superheat, so that you're really using as much of the heat transfer surface of the evaporator as possible, while not putting too much refrigerant in that evaporator and then risking liquid coming back to your compressor and potentially damaging that compressor. We've also got the sensors needed to make sure we're measuring the superheat accurately. And then finally, if you're going to go with a more standard fixed speed kind of rooftop design, Danfoss has our TGE mechanical expansion valve. It runs up to a bit over 40 tons. And if we look on that valve, it's also qualified for all the 410A alternatives, the A2Ls, R32, 452B, and 454B.
Thanks. So a whole lot of different options there, and we talk a lot about peak performance and system efficiency, and of course that's really, really important. But I know that the audience is going to be saying, okay, but are these things reliable? Because they're the ones, when they're out in the field, they've got to actually deliver. What can you say about that?
Right, yeah, and that's a fantastic point, David. Your rooftop or air handling unit is only as high quality as its the smallest component. So you need to make sure that you're putting as much effort into selecting high quality components as you are on the bigger items like your heat exchangers and your compressors. And there also Danfoss has full line of solenoid valves, ball valves, check valves, filter dryers to ensure that the system is operating at peak performance all the time. And critically, all of the components that we mentioned have all been tested and approved for use for these next generation refrigerants. So all the 410A alternatives that we've been discussing, and they've all gone through PED approvals so that we know that they're of a high quality so that they'll last a long time in the field.
Great, thank you. So, gentlemen, I think that what we're hearing is that a lot of change, a lot of different drivers and things going on, but that you guys have got lots of different options available for people developing applications in these two areas. Bringing it back full circle, Philippe, you pretty confident for the future with these units?
Yes, for sure, David. So we see the megatrend and regulation, and how that will drive changes for this application in the coming years. And Danfoss is ready to help its customer to move forward.
Oh, well, I think that's a lovely positive note to pull the discussion to a close there, because I'm sure that the audience will want to ask their own questions of you. And if you would like to do that, you can join these guys in our chat room in just a moment. We will provide a link for you for that. And as you can see, that there are links here where you can go online for more information and documentation. But do join us through in the chat channel for the Q&A just now. All these guys can't wait to hear from you, I'm sure. But in the meantime, I will draw the session to a close there. Gentlemen, thank you for joining us, and thank you too. Goodbye.
Thank you. Thanks, bye.
All right. Bye.